Hey guys, here's a little review for the rectangular approximation method that we learned today in class. We'll go ahead and we'll start with our left endpoint rectangular approximation method. We'll do 5 rectangles and we'll do it on our f of x. So what we ended up saying was you go ahead and you draw your rectangles using the left-hand endpoint as your starting point. So my starting point is going to be at 0, 0, and I'm going to go from the left all the way over to my next point. Now, obviously, I couldn't go up anything because I'm starting at 0, 0, so it seems kind of silly for this first rectangle. It's not even a rectangle. But you'll start to see it now as we go to our next endpoint. So 1 is my next endpoint. I go up to my curve, and I come over to my next endpoint and come down. Okay? So there's my second rectangle. Then I go up, over, down, up, over, down, and last one. And there's my 5 rectangles. So 1, 2, 3, 4, 5 rectangles using the left-hand endpoint. Again, I know the first one's technically not a rectangle, but just go with it. All right, so how do you find the area of a rectangle? Well, you do base times height. So base here is 1, and my height is 0. Not very exciting, but technically it's part of it. Plus my base of my second rectangle times my height. My height is going to be 1 squared. Since my function is x squared, the value at 1 is 1 squared. Plus the base times the height of the next rectangle, 1 times 2 squared. Plus base times height of the third rectangle, plus base times height of the fourth rectangle. I've got 1, 2, 3, 4, 5. The heights, here's a height. Well, technically, here's the first height, 0. Here's a height. Here's a height. Here's a height. And the last height here, all the way up to the curve. Okay? All the bases are 1 on purpose. We went from 0 to 5, and we made 5 rectangles. So that should work out. And we've got ourselves a total of, I believe this one ends up being 30. So you can quickly see, of course, we're way under the curve, right? There's lots of space completely unaccounted for under the curve. But it's at least a first, approximation. And that's the left-hand rectangular approximation method. If you want to do the right-hand rectangular approximation, we're basically going to do the exact same thing. But we're going to start with the right-hand endpoint. Up, and then back, and back, all the way up to the curve, come back, and then down. Still 5 rectangles. They're just constructed using a different endpoint, or a different height, I mean. Okay? So my first rectangle actually has a height of 1. Okay? My last rectangle actually has a height of 25. So the ones in the middle end up being the same areas, but they're just drawn differently. Okay? So my right-hand rectangular approximation method for 5 rectangles for f of x is going to be the base times the height plus the base times the height, so on and so forth. And it seems kind of silly to have to keep writing the 1. I'm just doing it for emphasis. But if it was a 2, you could just pull the 2 out. If it's a 1, obviously you don't even have to write it. I'm just showing it because it's really just base times height. Base times height plus base times height. And this one, if you do it up, you get 4, 5, 14, 30, and 25, so 55. So our first one, if you remember, our first one we had 30, right? There's our left-hand approximation. My second one was 55, so it's somewhere in between, right? Because this one is way above. Look at all this extra space. Look at all this extra space above the curve that, we're adding in extra. And if you go back here, look at all the space that we missed, right? We missed all this space, we missed all this space, etc., etc. So somewhere in between is a pretty good approximation. And somebody in class had mentioned, well, what if we just take the average of those two? Well, that's not a bad idea. You take the average of 30 and 55, right? 30 and 55 over 2, and you get what? 42.5, something like that, which is a pretty good approximation. We can do another approximation without having to do both calculations. In order to get that 42.5, you'd have to do LRAM, and RRAM and then take the average. What I'm suggesting is, what if we took MRAM? What if instead of using the left or the right, we actually used the midpoints instead? So instead of starting at 0 or starting at 1, let's go right in the middle. This first one's going to be tough to see. But watch the middle one here. Go up to the curve, come back for the left side, and to the right for the right side. And you've got a little bit of space above, a little bit of space below. It's not a perfect match, but you know what? At least it's one method that accounts for both. And I don't have to do two separate calculations. So up, 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 over and down, over and down, up, 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 over and down, over and down. Again, I got a little space above, I got a little space below. Above, below, above, below. Not a perfect match, but you know what? It's still better than, you know, all the way over or all the way under. So what would this be? My x values, I've got a half, 3 halves, 5 halves, 7 halves, and 9 halves. So my base, let's just say, I mean, the base is just 1, so I'm not even going to multiply by that anymore. You get the idea. I have 1 half squared plus 3 halves squared plus 5 halves squared plus 7 halves squared and 9 halves squared. So first of all, the denominator's got to be 4, 4, 4, 4. So I know it's something over 4. 1 plus 9 is 10, plus 25 is 35, plus 49 is 84, plus 81 is 165, which gives me 41.25. So I had 42.5 the other way. I had 55, which we knew was way off, and I had 30, which we knew was way off. So 42.5, 41.25, those are pretty good approximations for the area under x squared using only rectangles. And that's the rectangular approximation method. That should allow you to do page 324, numbers 2 and 5. Please let me know if you have any questions, and I will talk to you soon. Have a good one. Bye.